Okay guys, I just wanted to go back to this bit on deriving the quadratic formula, and I wanted to go over something that I skipped here just because there was a lot going on. So I'm actually going to erase some of what we did here. We know that what we were doing in deriving the quadratic formula was setting our formula, or this guy, to 0, and then completing the square to solve for our x values. So we did that. But what I wanted to draw your attention to actually is this bit right here. So I'm going to move it down. Okay, and I'm just going to show you something. So remember, we started with 0 equals ax squared plus bx plus c, and then we decided to complete the square. So if I just look at this function right here, I'm going to rewrite it without the 0. I'm going to rewrite it just as y. So basically what we did is we've taken a quadratic and we have rewritten it as a x plus b over 2a squared. And then if we want, we can write it like this. So essentially, what I want us to see here is we have this guy now in vertex form. So I've taken my quadratic and I've written it in vertex form, where this and this represent my vertex. Now I will say that this part is a little bit confusing, so we generally don't look at that, but what we will notice is that the x value of our vertex is negative b over 2a. So the moral of this story is, if I take y equals ax squared plus bx plus c, and I complete the square, okay, I get this guy, which tells me that the x value of my vertex is negative b over 2a. And of course, the way I can find the y value of my vertex is basically just by substituting, substituting x back into my function here to get my y value. Okay, so we're going to use that in the next part of our questions, and it's something that we're going to need to know for this unit.